Hey everybody, this is Larry. This is me doing week 3 of the November Leetcode weekly challenge. Hit the like button, hit subscribe, and join me in Discord. Let me know what you think about this problem. It turns out that I forgot there was a medium, not medium. This is medium, but a weekly problem, so I'm going to try to do that, squeeze it in, and then I'm going to pass out. But let's go. Without further ado, we have 259, three sums smaller. Given an array of n integer nums and an integer target, find the number of index triplets I, j, and k such that they're in this order and satisfy I plus j plus k is less than target. Okay. Excuse me. All right. Cool. The first thing I want to look at is the constraint, and n is 3500, but which means that we cannot do n cube, obviously, but we can't even do n square easily. It'll be very tight, right? However, the other thing is noticing that nums are only negative 100 and 100, and target is only negative 100 to 100. So we can definitely try to abuse the target and the nums, basically the range of the numbers, because they only could only be 200 numbers, right? So I think that's basically it, right? Because basically for each number, let me kind of write it out a little bit for visualization. What you might normally write is like right, for someone like this, and this is just to maintain this satisfy this condition, and then obviously do the other one. This is n cube and too slow. But what if you don't have to, right? What if now you start at k, which is the last number, and you just look at the previous pairs, right? Because basically we know that, or maybe I'll slow down a second, right? So let's say we get rid of the I layer and we just have j and k, right? Oops. Then now we only have to do a loop of 200 elements, right? Because when you loop 200 elements, because the I, it's almost like you're compressing them into things. If you have, like, for example, 5 2s, you're now doing them all at the same time instead of one at a time. So that's basically the idea there, right? Again, though, this is still n squared. It's gonna be too slow, but with that we can do it again, right? So then now instead get rid of j, and then instead of loop of 200 elements, we just do it twice. We do it once for the loop of 200 elements and then loop of 200 square elements, because that's the possibility of ranges, right? Or is it 200 square? It's either 200 square or 200 or 400. 200 times 2. I think it's actually just 400, right? You just have to do it twice, and then that's it, right? And maybe in that case, k doesn't make sense, but we can process them in a deliberate way, right? And what I mean by that is that, for example, we can say, let's just say x is a num. So we have current number, and then now we process this number as nums of I, meaning the first number, right? So then what will it look like? Well, maybe we just have fi is equal to a collections.counter, right? And then this part is as simple as writing f sub I of x increment by 1, because then now it can be used as I, right? But before we do that, and the order matters only because you don't want to count itself, then now we process this number as j, right? Process this number as nums of j, meaning the previous numbers. So we look at previous i's, right? And of course we have f sub I for that reason. So then we just do it for let's just say ki for key sub I, maybe in fi dot keys. Then now for each one we can do let's just say f of ij, which is I and j combined, right? We have x plus k sub I increment by 1, right? Because now for every previous number, which is k, for every previous num sub I number, well, actually this is wrong. Is actually f of I of x, right? Does that make sense? Or no, this is wrong again. This because for this one x, and every pairing we show up here, right? You could play around with numbers to kind of to see what that means, right? But this f sub I can at most have 200 unique keys. And in a similar way, now we process this number as num sub k. We look at previous i's and j's, which we have a thing for, right? So then now for k sub ij in f of ij dot keys, maybe. So then now, and you can actually do a little bit smarter than this, but we don't even have to. You can just write if kij. And kij should be the sum of all the, we did x plus ki, right? So that's the previous thing. So then it's this plus x. So maybe k for keys is maybe confusing. But if this is, what is it, less than target? Less than target, then we just add count to the number of times that appeared. And that's it. Pretty cool, right? Hopefully. Okay, quick submit. Yeah, and that's it. That's all I have for this one. Let me know what you think. Yeah, so obviously the X loop is O of N. This loop is O of R, let's just say. R is the range of numbers, which is actually in the description, which is 200 numbers. And then this is 2 times R, right? Because this can only be 2 times R. So yeah. So this is going to be O of N times 2 times R, which is N times R, which is 200 times 3,500, which is like, I don't know, 700,000 or something, right? So yeah, so we're definitely very good. And that's it. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.